Hey, students. It's good to be with you again on lecture 6.5 on fossil fuels. All right, this is a big one. I might even cut it in half and give you two pieces of this. So this is on page 11 in your notes, fossil fuels. It's a really big deal for apes. You can see I have some stuff about mining operations behind me, and then I'm going to show you guys some coal also. So let's go ahead and talk about the objectives for this lecture. Is that we are going to describe the use and methods of fossil fuels in power generation and describe the effects of fossil fuels on the environment. So this really is a big deal in environmental science. The first thing that you have is a video about fossil fuels. So this is a short about a little more than 4-minute video about fossil fuels. So you should watch this. And the way you can watch it is by finding it in the lecture. So you can go to the website, which has the lecture, and click on it, or you can click on the link that is in the doc for on page 11, okay? Or just look up how humans disrupted a cycle, and then you're going to watch that and take notes. So do that, and then I'm gonna keep going on with the lecture, and you'll be pausing and writing things down as you go. So the first thing you're writing down is fossil fuel. So you should write fossil fuels are derived from fossilized material that fossilized millions of years ago, about I always say 100 million years ago, 300 million years ago. And this was formed in anaerobic conditions, swamps mostly, and it's a non-renewable or finite supply. So we're going to talk about how fossil fuels are made. All right, so this is how they're made, and there's information on this in your textbook, and it's really important to understand. But the simple, oversimplified thing is that dead organic matter from 100 million years ago, it died, right? Plants, swamps, we'll talk about the different things and how they turned into different stuff. So mostly plants, but some dinosaurs, that's why fossil fuels, right? They were trapped, so they were alive, and then they died, and they got layered and smashed underground 100 millions of years. So time, took lots of time, heat, because it's deep, and pressure to transform dead organic matter into a fossil fuel, coal, oil, or natural gas. All right, so you should look at this closely. You have a picture, it's pretty small, but that's your basic idea. Dead organic matter, time, heat, and pressure, hundreds of millions of years, compressed, okay? And the reason there's energy in these is because the plants went through photosynthesis, and now there's energy to be burned. So we'll talk about how that's burned. So we have what's called combustion, right? Because that's how you get energy from these fuels. So oxygen combines with hydrocarbon to form water and carbon dioxide. That produces heat. So the general formulation is CX, where X could be any number, lots long chains of C's, long chains of X's. So a hydrocarbon, get it? Hydrogens and carbons. And you add oxygen, and then that gives you CO2 and H2O. So here's an example, C6H12O6 plus O2 gives you CO2 plus water. Does that remind you of anything that you've learned about in biology? It should. It should remind you of aerobic respiration. So in your cells go through cell respiration to make ATP. That's from biology, okay? So, hey, that reminds me of photosynthesis and cell respiration. So if you look at it in this direction, it's cell respiration. If you look at it in this direction, then it is photosynthesis, right? Plants take CO2 and water to make glucose and oxygen. So that's how it happened in the first place. This is how we got all these hydrocarbons, was through photosynthesis, and then you burn them, okay? So in our bodies, we are burning energy, just like in our cars, we are burning energy. So they both burn fuels to make energy. That's how your body works. So you're going to write these down, a comparison between cell respiration and combustion. And cell respiration really is combustion. Sounds weird to say you're burning things in your cells, but I really hope your bio teachers made a big deal about this. In your mitochondria, you are burning. The chemistry of burning is to add oxygen, so that's going to serve you well, okay? So you can pause and write down that cell respiration is slow and controlled versus fast, which is combustion. Cell respiration is at body temperature, combustion is at higher temperatures. Cell respiration happens in living cells. Combustion can happen anywhere. You can have fire and oxygen. And in cell respiration, energy is stored and released in steps. It's stored as ATP, but it's released in steps. And in combustion, it's released right away in the form of heat and light. So incomplete combustion is when there's not enough oxygen present. So the leftover carbon's being released as soot and carbon monoxide. So that's not carbon dioxide, that's just CO, carbon monoxide. So when you have complete combustion, you have CO2 and water. And incomplete combustion, you're left over with some carbon monoxide and then like all the soot and things that come off. And so you can see that if you've ever had like a candle and then you see all the soot at the top, that's when it's incomplete combustion. So here's the difference between complete combustion and incomplete combustion. So you're going to write these down on your notes on page 12. All right. So you can see the difference between complete and incomplete combustion. You can pause to write those down. All right. Now we're going to talk about coal. Coal is the most abundant and dirtiest of all of the fuels. So I can show you this. I have a piece of coal. This one is anthracite coal. And as soon as I get this out, my hands are going to get dirty. So maybe I'm not going to do this right now, but see, it's dirty. Well, all right, maybe I'll do it. All right, so this coal is dirty. All right, like my hands are already dirty here. I could draw on my paper with some coal. I'm drawing on my paper with some coal. So coal is abundant and dirty. Ugh, it's dirty. My coal, see, I drew on my paper. It says coal and I drew on it with coal. All right. So, sorry, that is out of focus. So it is a solid fuel formed from the remains of trees, ferns, and other plants that died and were preserved underground about 300 million years ago, MYA, million years ago. And it's ideal for stationary combustion applications. So it's not charcoal. We'll talk about that in a minute. It's not like the charcoal briquettes that you use in your barbecue. That is charred wood that will burn for a long time, and that is not old. This stuff's old, 100 million years old right here, which is actually kind of cool when you think about it, but it's so old. And it's stored up condensed solar energy. That's really what it is. Okay, so now in your study guide, you're going to have to say how things work. So we'll show this more when you're working on your study guide, but this is a good picture, so you could cut and paste this picture or find something like it. I think I might have put one in your study guide. So you need to know how you make electricity from coal, because if you remember, electricity is a secondary source. You don't just get it, you have to generate it. And so the way that you generate electricity from coal is you burn it. But you can't just burn it, you have to put it into a coal-fired power plant. And this is how it works. So on this figure that you have in your notes, you're going to write down these parts. So the first part is that coal is mined and transported. And I want you to think about all along the way, there's emissions. And that's why it's so dirty, because it's not like a lot of other things, like there's bad emissions at one place or another, but coal, it's dirty the whole way through. So we've gotten much better and cleaner at coal, but nowhere near to the kind of idea of what clean coal is. All right, so coal is mined and transported. Then it's burned in a boiler. So you put the coal in and you burn it. And then you use water. So the energy is transferred to water to make steam. And what happens when the steam is rising, it'll make these turbines turn. So there's steam. So, and then first you got to use water too, right? Like water is a precious resource and you can't just use salt water. You need lots and lots of water. Now you can condense it and keep reboiling it, but you have to have a constant supply of water. All right. So you put in the coal and the water and you boil it, and then the steam rises and turns these turbines. Okay. Once you have turning turbines, okay, so then the steam turns the turbine and the turbine turns a generator. So a generator is a magnet with wires and it generates electrons. I have a generator right here. So this thing right here, if you see, is a magnet, and then the copper wire is right there. And if I turn it by pushing it here, so I start to spin that magnet. It's a little hard to see the magnet spinning, but see, look, I'm turning on a light. Anytime you can spin a magnet and wires, it generates an electrical flow. So this one is a hand crank generator. I'm using my energy from my body to turn the turbine, to turn the generator to generate electrons. Okay, so this is just a huge one, gigantic room size, bigger than this room, giant turbines, giant generators, and that generates a flow of electrons. There's our electricity. Okay, we will be going over lots of different ways to make electricity. So I want you to remember, even though this is the primary way, one of the primary ways that we make electricity in the United States and around the world, actually. So we use a lot of water and there's lots of emissions. Okay, so fill that whole thing out and really learn and understand how it works. Okay, that's a coal burning power plant, makes electricity. Okay, I'm going to skip that. All right, so the types of coal. So remember we were talking about, we have peat that is not coal. So I have some peat in a bag here. And this is plant matter in swamps, and you can burn it. It's very, very dirty. Then the next one is lignite, and lignite is brown coal. It's just hard to see these in these, and I don't feel like getting them all out right now, but lignite is a little bit less shiny, and it's a lower heat content. It's not as old or compressed or as potent as, say, bituminous. So bituminous coal is soft coal, and it is not as shiny and hard as our gorgeous, most important, most expensive anthracite. And anthracite coal is the most in demand, and it is getting used up the fastest. So even though we have a lot of this, it's an abundant supply, we're still going to run out. Okay, so here's where you're going to go back to your map, that page 10 in your map that you did for lecture, what was that, 6.3, I think, or maybe 6.4. So now you can go in and draw, just sort of like get a coal color, maybe, you know, maybe use your pencil color or something for this. And you can kind of be like, okay, there's some coal here, there's some coal here, there's some here and here and here. I'm pretty sure that the orange is bituminous and then the green is anthracite. I'm not 100% sure though. And so you can see that it's not all over the United States, right? So you'll pause on that and just kind of sketch in where there's coal in the world on your map. And then see, you might wonder, growing up as a Californian, if you did, like I did, what's the big deal with coal? Like, I don't even get it. I've never even seen coal. Well, that's because there's no coal to speak of in California, barely any. And if at all, it's like medium volatile bituminous. The anthracite's the good stuff. So there's anthracite here in Virginia. And so when you start to talk about where coal is, you're going to be talking about these areas here. So these are what's called coal country, and this is why in California we don't hear about it as much. So here's the advantages. The advantages are that it's abundant. There's abundant reserves compared to oil and gas, okay? So you can see like how much is left and, you know, how long we might have. And there's a lot of different ideas about exactly how long we'll have, but maybe 400 years even, or something like that, okay? Then number two is the ease of extraction through surface mining. So it's low technological demands and low cost. And part of that is because we've been investing in coal since the 20s. It's way cheaper than it used to be, and it's much safer than it used to be. But a lot of people have died, and a lot of technology has been expanded so that it is cheap and low cost, because we've done a lot of investment. It's safe storage for future needs because you can cover it up and have it whenever you need it. It's an ease of transportation. There's no pipelines or extra security. So you can just take it around. Now, it does give off emissions and dirt and dust and stuff. They're environmental problems, but these are better economic issues. It needs little refining, so you can just get it and put it into your coal-fired power plant. So this is charcoal, right? Remember I told you this is not old stuff. This is not coal. It is charcoal. And charcoal briquettes can be used to barbecue. Okay, so you probably know about that. So here's the disadvantages of coal, and they are big, and there's just no way around them. We really, for the environment, should get off coal. So surface mining, there's tailings that contaminate waterways. So the stuff that's left over from coal mining gets washed into waterways. Those are called tailings. There's lots of air pollution. All right, so way more air pollution from coal than from oil and natural gas. There's impurities released when it's burned, sulfur, mercury, lead, arsenic, and then sulfur dioxide in the air leads to acid rain. And it is mostly carbon, so it's converted into CO2. Actually, it's great when it's converted into CO2 instead of CO or some of these other sooty type emissions, because that's where you get most of your air pollution. CO2, when it's completely combusted, when it's a complete combustion, it makes CO2, which is a heat trapping gas, but that's the cleanest thing you could get from coal because of what it is. It's hydrocarbons. There's residual ash. So up to 20% remains after as ash, because you burn the coal, you still have a lot of ash left over. And there's been huge ash spills where all the leftover junk from the coal-fired power plant, where you burned it down to unusable waste. So in Knoxville, there was this huge ash spill, and it took 5 years and $1 billion to clean it up. A lot of what you're going to hear with the fossil fuels is like, they're great when nothing goes wrong. There's all this waste, but just hold it somewhere. It always gets out, like oil spills and gas leaks, and there's just always this problem with spills and disasters. Okay, so this is a video on how to create cleaner coal. So you guys can go to this. This is a link in your packet, and you can watch that, and it explains some things. So you're going to take notes on this video that you can get to by the link that's in your packet, or you can go to this again. You can go to the whole actual slideshow in the website. Okay, and then okay, so then there's the major coal producer files bankruptcy. You can skip that, the stuff on page 14. You can also skip tuna's declining mercury contamination is linked to coal. So there's tons of problems with these things. We probably are going to skip both of these, but feel free to look at them if you want to. That is up to you. Okay, so now we're at petroleum, and let me pause for just a minute and see where we are. Okay, so I think I'm going to stop there for this one. So this will be 6.5 coal. And then the next one's going to be 6.5 petroleum. And I'll let you guys know that one when I get to it. See ya.